Alright, this should be the final video for 2012. We've got a question here that talks about a particle moving along the x-axis. Its velocity is given by this equation. It also tells us that we start at -2, which will probably come in handy. So from 0 to 12, when is it moving to the left? So moving to the left would mean velocity was negative. So that's all I need to find out. I have a velocity equation. I know it's a trigonometry function, but we should be able to make some sense of this. So what I really want to know to start for part A is when is cosine of pi over 6t equal to 0? And I don't know, for me the easiest way to do this is to think about the function not cosine pi over 6t, but think about the function, cosine of t. So cosine of t equals 0. Lots of places. That's a pretty bad graph, but pi over 2, 3 pi over 2, 5, 7, 9, etc. So normally we would say something like, well, when t equals pi over 2, or t equals 3 pi over 2, okay? But for us, it's not t, it's pi over 6t equals pi over 2, pi over 6t equals 3 pi over 2, and etc. And we do enough of those that when we solve for t, we get an answer, but the answer has to be between 0 and 12. So I'm not sure yet how many of these I would need. So multiply both sides by 6 over pi. And I get pi cancels out, and I'm left with time equals 3. I'll do it again. Pi's cancel. 2 goes into 6, 3. 3 times 3 is 9. And we'll do one more. So pi over 6t equals, so 3 pi over 2, 5 pi over 2. Multiply by 6 over pi. 2 reduces to 3. 3 times 5, that's 15. That is too big. So it must be there. Okay, so now I know where it's 0, at 3, and at 9. But the basic structure of cosine hasn't changed. So we know it's still going to look like this. And so now I know that this goes from positive to negative, and then negative to positive, which really isn't relevant for this question, but maybe it'll come in handy in a minute. So when's it moving to the left? Between 3 and 9. So notice it doesn't say to explain, but they're going to want to see the math that led to my answer, so make sure that's roughly clear. I think mine's good enough. So from time equal 3 to time equal 9. If they ask for an explanation, my sign chart isn't good enough. Having a negative here isn't good enough. We would want to say because it's negative there. But they didn't ask, so I don't care. Okay, part B. Write but do not evaluate an integral expression that tells me the total distance that I've traveled from 0 to 6. Alright, so this is actually kind of an interesting question. I could do it a couple of ways. The total distance traveled would be the integral, but only of the individual pieces, and then add it up as positives. So I can either answer the question by saying from 0 to 3 of the velocity plus 3 to 6 of the velocity. I could probably just say v of t or whatever they named it. But this piece is going to be negative, so I could do that. So write but do not evaluate an integral expression gives you the total distance. Or what could have been done is I could have just said from 0 to 6. So I took all the negative parts and I made them positive. The other way to do that would be just to take the absolute value of velocity. Oops, that's the absolute value sign. And that would do the same thing. So either of these should be fine. And part B doesn't ask us to find it, just an expression for total distance. That has nothing to do with the initial value, so just how far did you go? I went some positive, I turned around and went some negative, add them together both as positives. Alright, let's go to part C. Find the acceleration of the particle at time t. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time 4? Okay, so they're asking me to find the equation. So the velocity equation was cosine of pi over 6t. So the derivative of velocity, which is acceleration, is going to be negative sine of pi over 6t times pi over 6. Now they want me to evaluate it at time equal 4. So I get negative sine of 4, and for t makes it 2/3 pi times pi over 6. So now I got to think about the graph of sine. So I go to sine. So this is pi. This is pi over 2. They're asking about 2/3 pi, which this would be 3/3 pi at pi. So we're in here someplace. So that's a guess of my answer, and I can get the exact number if I want. And maybe that's something I should do. But essentially at this point I already know that that's positive times a negative, so equals a negative number. Alright, so basically what it comes down to is how do you want to explain it? You need to tell them that this is a negative number, and you might need to tell them why. So if you don't actually find that value, you have to explain how you know it's negative, and it might just be easier to find the value. So for me to answer what's the actual number, I think about a unit circle, and we're talking about 2 pi over 3, which would be over here, which is going to be a pi over 3, that's really small, shy of a full 2 pi. And so now they just want the sine of this. So pi over 3 is 60 degrees. So this is 1, this is 2, this is the square root of 3, and that's negative. So the sine is going to be root 3 over 2. So I get negative pi over 6 times root 3 over 2. So negative pi root 3 over 12. So now I could say find the acceleration of the particle, and now they want to know about the speed. Okay, is the speed increasing or decreasing, or neither? So now we got to look at the two together. What is velocity doing at time 4? What is acceleration doing at time 4? So back up here on part A, we found that velocity was negative from 3 to 9. We found velocity or acceleration is negative at 4. So what that means is they're both negative. So that means I'm slowing down. So what was the specific question here? Is the speed of the particle increasing or decreasing? So I'm going to say the speed is increasing because velocity and acceleration are both less than 0, or both negative, I guess I could say. are both negative, and that's probably good enough. Part D. Find the position at time 4. So I just need to, where did I figure out where I started? Started at -2, and then I did some change. So I got to figure out what that change was. So my answer should simply be -2 plus whatever happened. And what happened was from 0 to 12, I changed at a rate of cosine pi over 6t. Some positive, some negative. I just want the net area, so that'll give me the displacement, and I can add it to my initial value. Okay, so I got to do the antiderivative cosine of pi over 6, which should just be sine of pi over 6 times 6 over pi. Because I have to account for the chain rule when I take the derivative to make it equal this. I need a t in there, excuse me. So the derivative of sine of pi over 6t would be cosine of pi over 6t times pi over 6. And then since I have 6 over pi, those will cancel, and I'm good. Stop and try it yourself if you need to. And so now I need to evaluate it from 0 to 12. So I plug in 12 and I get 6 over pi times sine of 2 pi minus 6 over pi times the sine of 0. And this is interesting because the sine of 2 pi is 0. The sine of 0 is 0. So that means I didn't go anywhere. My displacement was 0. So -2 plus 0 equals -2, which is kind of weird. I mean, it makes sense in one hand, but it's just not what I expected as an answer. So I'm wondering if I made a mistake. So let's go find out. All right. So here's the answers. Let's see what it says. All right. Stop it. Okay. V of t is this, from 3 to 9. The particle is moving to the left when velocity is less than 0, and that's from 3 to 9. There you go. Here's their very easy answer for part B, which you remember we tried 2 ways, and we came up with the easy way as well. Part C, we found a negative pi root 3 over 12. Negative pi root 3 over 12 is less than 0. Velocity is less than 0. Speed is increasing because velocity and acceleration have the same sign. We said the speed is increasing are both negative, so we almost said it word for word. And let's see how we did on D. Okay, yeah, we made a mistake someplace. Oh, you know where we made a mistake? Is probably you were screaming at the television the whole time. I didn't reread the question. I didn't scroll back up. It only wanted to go from 0 to 4, and I went all the way to 12. So we got the right antiderivative. They plugged in 4, and they got a number out of that. They plugged in 0 and didn't, and then they got their answer. Okay, so I made a mistake. Probably would have not gotten, probably just this last point. I think the rest of it would have been fine. Anyway, so there's your correct answer. And there you go. That's the last video. Oh, let's quickly check how well people did. That's not what I want. Let's see if I can find it real quick. To move stuff out of the way here. I closed it. All right. That's not it either. Pretty riveting. Forget it. not sure why it's not coming up. Okay, anyway, I'm sure the average was pretty bad and we beat that. So anyway, that's it.